Let's do some pandas. Highest paid employee by department. This question appeared in the interviews of Amazon and Asana. In this question, they're asking, determine the highest salary and employee ID for each department. Your output should contain department, worker ID, and their corresponding salary. Note, in the event of a tie, output both worker IDs. So this is a pandas question. I have solved the same question using SQL in my other video. You can go check it out if you want to look at how I solved this in SQL. Because in the SQL approach, I used window function, which is the easiest approach there is to solve this type of problem. So there's a pattern here, right? They're actually asking us highest salary for each department, right? You can use group by, just in SQL, you can use group by as well. But there's a better approach. You can use a window function. So in SQL problem, I use the window function. I'll use the same logic here, but I'll use it for pandas. So first thing first, let's explore this data set here, the worker data set. Let's see what we have. The first thing we do here in pandas, we do import pandas as PD. And then let's see what we have. We have worker data frame, and let's explore this. And let's see what we get. Okay. This is the data frame we have. We have 5 records here, obviously, because I'm using head. Worker ID, first name, last name, salary, joining date, department. So what they're essentially asking us here is, in every department, give me the person with the highest salary. So for example, in HR, who is the person with the highest salary? In the admin, who is the person with the highest salary? So again, as I mentioned, I'll be using a window function, and it might be your first time watching a window function being used in pandas, so pay attention. It's not that difficult actually, it's pretty simple. So what I'm going to do here is, let's assign this worker data frame to something called df, right? Df always makes it easy. I mean, you can just leave it worker, but in my case, I'll assign it to df. It just makes my life so much easier to work with, right? So essentially what I'm going to be doing is I'm going to be adding one more column here. So we have 6 columns here. I'm going to be adding a 7th column here, ranking column. That column will contain the rank. What exactly is a rank? I'll explain that to you real quick. So let's make that column here, let's call it dense rank, because that's the type of ranking I'm using. So I'm making this new column dense rank, and I'm grouping by group by department, because I need to group by department. And then in that department, let's focus on the salary column. And then now let's assign the ranking. So we have done the group by department, and now we are looking at the salary column in that group by, and I need to rank now. I want to rank the highest person in that department with the rank 1. Okay, so that's why I'm using this method called dense rank. You can read up more about ranks and stuff like that. There's the pandas documentation. You can read more on that if you want. This is pandas data frame.rank documentation. But coming back to our problem here, .rank method, as I mentioned, will be the dense rank. So this will be dense. Ascending will be false, because I want that sorted order to be in descending order. Okay, that's why I'm saying ascending equals false. Why descending order? Because I want the highest salary person to be ranked number 1. So that's why I want that person on top. That's why I'm using ascending equals false. And everything looks good. And you know what? Let's make this a type integer. So as type int, let's make this column type integer. And now I think we have a new column. Let's run this. Name df is not defined. Okay, perfect. So now let's explore our table again. df.head. And as you can see, now we have this this new column here, dense rank. And in that dense rank column, we can see the rank 1 here. That means HR, in the HR department, this person here has the highest salary. In the admin department, that means this person has the highest salary because he has the rank 1. right? But as you can see, we have a tie here in admin department because we have two people with the same salaries, this guy and this guy, and they both have the same rank 1. Okay, that's pretty good. So in a nutshell, we have a new column now that contains the rank based on the highest salaries for that department. Okay, now easy things. Now what I want to do is, they're asking the question, output should contain the department, worker ID, and the corresponding salary, right? So now what I'm going to do here is, let's do our filtration here, because I only want records with the rank 1, right? That means those are the records with the highest salary in that department. So df rank equals 1, and this will give me a boolean here, obviously. Now, so let's apply this to our original data frame. This will give me all the records with the rank 1. Perfect. But they're only asking for 3 columns: department, worker ID, and their salary. So let's select those guys. Again, we're going to be using double square brackets because we're selecting multiple columns. Department. Then they're asking worker ID. And they're asking salary. And let's see. Perfect. As you can see, we have department, worker ID, and salary. In the department, we have HR with the worker ID 3. This guy is making the highest salary here with 300,000. Admin actually has 2 records which are making exactly the same salary, which takes care of this part here. In the event of tie, output both worker IDs, which we are doing here for the admin department. In the account department, this guy is making the highest salary, worker ID 6. So yeah, there you have it. Let's see if that's the right answer. And there you go, that's the right answer. Essentially, we used window function and pandas, which is pretty amazing. We used the typical group by. We focused on the salary column. In the salary column, we did a ranking using the dot rank method, and specifically the dense rank method. That's why you have to specify the method equals dense in descending order. And that's it. That's pretty much it.